All right, this is a video tutorial for the Big Ideas Geometry textbook, section 1.5, Measuring and Constructing Angles. The two learning objectives for this section are that you can measure and classify angles, and that you can identify congruent angles. So one major core concept that we're going to be talking about today are angles. A couple different important parts of an angle are the sides and the vertex. So the vertex has the same endpoint of both of those sides. You may also see in the definition the word rays, because again, you are starting a ray at the vertex, and it's continuing on through another point infinitely, but it starts at that vertex. So in this description picture, the point A is considered your vertex. Then the two sides of your angle would be line AB and line AC. Now, another thing to be aware of is the difference between your exterior and interior angle. We'll be talking about both of those later on in the course, but the interior is the area between your sides, and the exterior is the area outside of your sides. All right, so we have our first example. You have a lighthouse keeper measures the angles between M, J, K, and L are your other points. So what are the three angles that are shown within your diagram? So one important thing to be aware of is when a point is your vertex of more than one angle, you cannot just use that vertex point alone to name that angle. You need to use other letters that incorporate that angle. So this red highlighted arrow would be your top portion of the angle. Your sides would be JM and KM with a vertex of M. So depending on the order of which you do these, the only thing that is in common is that your vertex has to be in the middle of your angle name. So you're going from line JM to MK. You cannot put J and K together because there is not a line that connects those two. Your vertex has to be in the middle. Or if you wanted to go in reverse order, you could say KMJ. Both of those two angles name the exact same thing. So we're going to move on to the second angle. And again, we're looking at the sides KM and LM. Again, using the same naming terms, your vertex has to be in the middle. So you could start with KML, or you could flip it in reverse order and do LMK. Now the final one is going to be the larger angle that is around both sides. So you have the side JM and LM. Again, your vertex is the point that has to be in the middle. So your M is between your J and L, and you could say JML, or you could flip it reverse LMJ. And those would be three names of the angle in the diagram. So a couple different types of angles that hopefully you have already seen before. An acute angle is anything that is measured between 0 and 90 degrees. So anything up to 89 with decimals, as long as it's less than 90, it is an acute angle. A right angle is one that is measured exactly 90 degrees. And in a diagram, you may see that box around the corner of your angle to indicate that it is exactly 90. Obtuse is anything that is greater than 90 degrees, but less than 180, because if you get all the way up to 180, it is a straight angle. It's called a straight angle because usually it's just a straight line through that point. Okay, so using a protractor to find the measure of each angle. Now, some of these problems you're going to be shown on a protractor. You're not going to actually look at a physical protractor in front of you. It's going to be on the screen. So it's really important to be able to read where these angles are on the protractor, because there are two different directions. If you notice, all the way on the opposite sides, you have a 0 and a 180, but one is on top of the other. And that's going to help you determine on where your starting point is, whether you're on the outside track or the inside track. So let's look at JHK first. And that is going to be starting at your GH, and that is going to line up with your 0 degrees on the outer side of the protractor. So if I take away that red arrow, notice how your 0 is on the outside of your 180. It's furthest away from the H. So that's where we're going to start and look at the measure on the outside of the numbers. And we're going to go all the way up to K, and the outside number that goes through GHK of that line is halfway between 120 and 130 or 125 degrees. And it would be considered an obtuse angle because it is greater than 90, but less than 180. Okay, part B, JHL. We're going to go ahead and start with the side that is JH because it is pointing to the right. And again, this time it's going to line up with the 0 on the inner scale of the protractor, the inside track. So again, if I take away that line, you can see that the 0 is on the inside. So that's the set of numbers we're going to be looking at for our other side. So HJ lines up with that. We're going to go ahead and go all the way up to L. On the inside track, it passes through 90 degrees. And we know that any angle measure that is exactly 90 would be considered a right angle. Okay, part C, we're going to do LHK. This time it is not starting on any of the zeros. It's passing through 90 degrees. So when we find our other side, it's going to pass through 55 on the inner scale. So you could do either the inner or the outer, but as long as you are looking at which number you're starting with for your other side, since HL is passing through 90 on both the inner or the outer, you could have chosen either option, but just be consistent when you're looking at sides that are not on a 0. So we're starting at 90 and then we're getting to 55. The way you figure out the angle between them is to just take the difference. 90 minus 55 is 35 degrees. And since that is less than 90 but greater than 0, that would be considered an acute angle. All right, so some angle pairs. Given that the measure of angle LKN is 145 degrees, find the measure of angle LKM and the measure of angle MKN. That crooked little L after your lowercase m is the symbol for angle. So angle LKN is 145. What is LKM and MKN? Well, we're given in this other diagram to the right an algebraic expression that measures LKM and MKN. So if we know the entire thing is going to equal 145, we're going to set up an equation saying that each of the parts adds up to the whole. Well, if the whole thing is 145, we're going to take each left and right part, add them together using an angle addition postulate, because anytime you take something into different pieces and you want to put it back together, you just add them. So we know that the whole thing is 145 degrees. You're going to plug in LKM for the 2x plus 10 because that is the expression measured in your LKM. And then you're going to add that to 4x minus 3 for your MKN, which is the angle expression on the right. Okay, so then we need to solve for x. Combine like terms, 2x and your 4x are in common. Those get added to equal 6x. And then your positive 10 and your negative 3 combine to equal positive 7. Then using your inverse order of operations or your PEMDAS backwards, we're going to subtract 7 on both sides to give us 138 equal to 6x. And since the 6 is being multiplied by the x, you divide on both sides to get 23. Now the directions ask us to find the measure of LKM and the measure of MKN. We just found x. That is not what the directions are asking. We need to then plug this x value back into both LKM and MKN to simplify down to get the measure of our angles. So since LKM was 2x plus 10, we now know that since x is 23, we can substitute that in. 2 times 23 plus 10. Again, still following our order of operations, multiplying first before you add will give you a total of 56. Then we're going to do the exact same thing with our MKN. We know that it's 4x minus 3 But since we found our x to be 23, we're going to substitute the 23 into the x. Again, following your PEMDAS and multiplying first, then subtracting will give you a total of 89 degrees. One way to check this is to make sure that if these two angles are added together, they must equal your 145, which is the total that you originally added it to. Okay, identify the congruent angles labeled in the design, knowing that ADC is 140, what is the measure of EFG? So there are a couple different angle measures inside this quilt. The different markings will help you indicate on which angles are congruent to each other. So notice how in the diagram, the matching arcs, where you see one arc, those are going to be pairs of congruent angles. Where you see two arcs, those are going to be pairs of congruent angles. So this particular diagram has two pairs of congruent angles. The first one is your measures with your one arc or your single arc. And again, we're going to have to use three different letters to describe our angles where your vertex is in the middle. So the first one, ABC, your B is in the middle because that's your middle point. The other two sides are on the outside. FGH, again, same thing. Your F is on the outside, your H is on the outside, your G is your point in the middle. Doing the same thing with the two arcs, ADC, where your D is in the middle, and EFG, where your F is in the middle. So those are your pairs of congruent angles. Again, just look at the diagram. Any markings that you see will help you figure out what's congruent. Then part B, if you know that the measure of angle ADC is 140, what is the measure of EFG? Well, luckily, we just determined that since ADC is congruent or equal to measure of angle EFG, you just plug it in. If they're the same, 140 equals 140. Your EFG is also equal to 140. That's another word for congruent. All right, an angle bisector is a ray that divides an angle into two angles that are congruent. So that prefix bi means two. You're taking an entire angle, you're drawing a ray between them that cuts it into two equal congruent parts. So you are cutting this angle in half, is what a bisector does. So if QS bisects the whole angle PQR, and the measure of PQS is 24, what is the measure of PQR? So one thing that is going to be helpful for this is to just draw out the diagram. So draw out your picture of the measure of angle PQR as your whole angle, the whole thing, and then draw a ray QS that is bisecting that or cutting the angle in half. And you're also given that the measure of angle PQS is 24 degrees. What is the measure of the other one? Well, based on the fact that the angle is being bisected, you know that both sides are going to be equal because that's the definition of what a bisector does. It cuts the angle in half. So your RQS is going to be the exact same thing as your PQS. Since you're given that it is angle 24, you know that RQS is also equal to 24. That's not what the directions are asking though. The directions ask to find the measure of PQR, which is the entire angle. So your entire angle is made up of two parts of 24 degrees, and to find the whole, you just add the two angles together. 24 plus 24, boom, measure of PQR is 48 degrees. All right, so hopefully that helps. That is the end of the video.